In this video, we're going to talk about the rational root theorem. First thing is, let's talk about what a rational number is. Because a root is a number. So a rational root is a rational number. A rational number can be written as a over b, a fraction, where a and b are integers. Remember, integers have 0 and 1 and 2 and 3 forever. It also has -1 and -2 and -3 forever. And the denominator b is not 0. Rational number is the division of two integers where the bottom number is not 0. 7 over 0, as clear as can be, is the division of two integers. But we're dividing by 0, so it's not a rational number. 0 over -4 is a rational number. Because 0, the top number is an integer, the bottom number is an integer, and the bottom number is not 0. 0.8 over the square root of 13, at least the way it's written, it's not a rational number. In fact, you can't write it as a rational number. However, if you have 3 square root of 7 divided by 13 square root of 7, the top number is not an integer, the bottom number is not an integer, but I can write it this way because that cancels out. And now, that's an integer, and the bottom number is not 0. That is 3 square root of 7 divided by 13 square root of 7 is a rational number. What rational number? 3 over 13. If you have 7 times pi over 8 times pi, this is 7 over 8. The top's an integer, the bottom's an integer, the bottom is not 0. This is a rational number. This is a rational number. This number is not rational. Not because of the 0.8, but because of the radical 13. Now, for example, if you have 0.8 over 0.5, neither of those are integers, but if I multiply each of them by 10, that is, I move the decimal on the top and the bottom one place to the right, I get the division of two integers, and the bottom is not 0. Those are rational numbers. Now, how do you list the possible rational roots of a polynomial? List the possible rational roots for, let's see, how about 3x squared minus 4x plus 6? And the way you do it is you take the constant and you ask yourself, what numbers go into the constant evenly? The answers are 1 and -1 go in evenly, 2 and -2 go in evenly, 3 and -3 go into 6 evenly, 4 does not, 5 does not, or plus minus 5 does not, but 6 does. That is, plus minus 6 go into that constant. Now, you go to the leading coefficient, the one with the largest power of x. The coefficient is 3. What numbers go into 3? Plus minus 1 and plus minus 3. Now, we want to form all fractions where the numerator is one of those 8 numbers. There are 8 numbers that are circled. They are plus 1, minus 1, positive 2, negative 2, positive 3, negative 3, positive 6, or just 6, and negative 6. 1, 2, 3, 4, 5, 6, 7, 8. And in the bottom, there are 4 numbers. We want to divide. We want to find all the fraction where the numerator comes from the constant and the denominator comes from their leading coefficient. Now, let's just get through with this right away. If you have plus minus 1 and you divide it plus minus a and you divide it by plus minus b, there's a number of possible fractions we get. You can have positive a divided by b. You can have positive a divided by negative b. So I divided positive a by each of the possible denominators, b, negative b. And now I'm going to take negative a and I'm going to divide them by the possible denominators, namely positive b and negative b. Now let's see what we get. That will just be a over b, because the positive over positive is positive. This one, well, positive over negative is negative a over b. Oh, negative over positive is negative. That's negative a over b. And negative over negative is positive. Positive a over b, or just a over b. Let's put positive. Notice that this one's a repeat of that one, and this last one is a repeat of the first one. That is, what we get when we divide those two numbers, we either get positive a over b or negative a over b. So and I didn't even tell you what a and b are. This is true for any a and b. When you divide these, you're either going to get plus a over b or negative a over b. One of the two. Okay, so we argued that. Now, let us take the first number on top divided by the first number on the bottom. 1 over 1 is 1. First number on top divided by the second number on the bottom. 1 over 3 plus minus. So we're done with the plus minus 1. We want to divide, we want to write down every fraction where one of the numbers is the top number. One of the numbers, the numerator comes from that list, and the denominator comes from this list. So now start with 2. If you do 2 divided by 1, we'll get plus minus 2. If you do 2 divided by 3, or plus minus 2 divided by plus minus 3, you get plus minus 2/3. So I divided 2 by each of the possible denominators. So 2 is gone. Now we go with 3. You do 3 divided by plus minus 1, you get plus minus 3. Now if you do 3 divided by 3, that's 1, plus minus 1. Oh, I already have that. Let's not put it down again. Now we go with the 6. The 3 is done. Plus minus 6 divided by plus minus 1, that's plus minus 6. Then we do plus minus 6 divided by plus minus 3. But 6 over 3 is 2. So we get plus minus 2. Oh, I already have it. These are, let's write these. These are the only possible rational roots. That is, it is possible that a root for that could be, let's use this number, it could be x is 2/3. It could be that x is negative 2/3. It could be x is 3 or x is negative 3. A rational root for this could be plus minus 1/3. Plus or minus 1/3. Okay, or it can be none of these. If it's none of them, then there are no rational roots. There can be complex roots, there could be irrational roots. How would you find out what's going on? How would you find out if one of these is an irrational root? You use synthetic division. Remember, if positive 2 is a root, that means when I plug 2 in here, I'm supposed to get 0. Well, I know how to evaluate that at 2. I can just do synthetic division with 2 in front. 3x squared, negative 4x is constant. 2 times 3 is 6. You subtract, you get 2. 2 times 2 is 4. You add, you get 10. You didn't get 0. That means 2 is not a 0, a rational 0 for this. Now, you may say, well, how can 2 be a rational 0 anyways? Well, I can write it as a rational number. I can write it as 2 over 1. I can think of it as 4 over 2. I can think of it as negative 6 over negative 3. That is a rational number. Why? Because I was able to write it as the division of two integers where the bottom integer was not 0. While we're at it, let's try negative 2. Is negative 2 a 0? You add, multiply by negative 2. You add, you get negative 10. Multiply by negative 2, you get 20. You add, you get 26. It's not 0. So I know for sure that 2 and negative 2 are not rational zeros. So you can try the other 10 to find a rational 0. Now, just for the record, once you find one, let's just say 2/3 is a 0. It probably isn't, but let's make believe. 3x squared, negative 4x's, and 6. Put a 0 down. You know, we put our numbers here, we put our numbers here, and it ends up that we get 0 here. Okay, well, remember, this was x squared. This was x squared. So if this number was a, we'll have ax plus, call that b, plus b. That would be the other factor. And to find out when that is equal to 0, you know that x is negative b over a. So once you find one of them, you'll knock down this quadratic equation, this second degree equation. You'll get a linear equation. You will now know that 3x squared minus 4x plus 6 is x minus this number. And then, I think it's called the discriminant. What you got from here, ax plus b, that's the other factor. So either x is 3 over 2 or x is negative b over a. But again, probably 3 over 2 is not a 0. In fact, just in case it is, why don't we try it, and if it doesn't work, we'll move on to the next problem. And also, we get to deal with fractions. 3 plus 0 is 3. Now 3 times 3 halves is 9 quarters. Now, it'd be real friendly to write negative 4 with the 4 on the bottom. But that's easy. 4 times negative 4 is negative 16. So you have negative 4 plus 9 over 4, which is negative 7 quarters. Negative 7 quarters. Now, you take negative 7 quarters and you multiply it by the number in front, and you get negative 21 over 8. Negative 21 over 8. Now, you want to add those two numbers. It'd be really nice if you can write 6 with an 8 on the bottom. But that's trivial. 8 times 6 is 48. So 6 minus 21 over 8 is 27 over 8. And unfortunately, that's not 0. But if it were 0, then this would give us the other factor. That would give us the other factor. And the original factor, since that was a 0, which it isn't, but let's make believe it was, that would give you x minus 3 over 2. So either x is 3 over 2, or you want to know when this is 0. Well, if you subtract two quantities and you get 0, if you subtract those two values and you get 0, it has to be because they were equal to one another. On the left side, it's very, very friendly to divide by 3. On the right side, you don't want to divide by 3. That's messy. How about we multiply by the reciprocal? 7 times 1, 4 times 3. That would be the other 0. Okay. Go through go through the possible rational roots until you find one that worked. And if you have a quadratic, what you will be left with is a linear equation. So you'll have both factors. I want you to think about that. Can't show you everything. You have to think a bit. What are the possible rational roots for this? You have 3x squared minus 6x to the 5th plus 2x minus 8. Well, the constant is negative 8 or 8. The numbers that go into 8 or negative 8 are the same. 1, 2, 4, and 8. Notice that I also include the negatives. The leading coefficient, the one that has the highest power, is negative 6. It is not arbitrarily always the first one. So it's 3. And then you ask yourself, which numbers go into 3? And 3 doesn't have many numbers that goes into itself. And it turns out that the only numbers that go into 3 are 1 and 3. Okay. There are 8 numbers on top, 4 numbers on the bottom. So the problem is to list the possible rational zeros. So let's use plus minus 1 for the top. You divide it by plus minus 1 in the bottom. 1 over 1 is 1. You get plus minus 1. Then you do plus minus 1 divided by plus minus 3. 1 divided by 3 is 1/3 plus minus. When it came to plus minus 1, we used all the possible denominators, namely plus minus 1 and plus minus 3. Now we do the same thing with plus minus 2. We divide it by 1. 2 over 1 is 2 plus minus. Then we divide the 2 by the 3. And we get plus minus 2/3. I divided the plus minus 2 by every possible denominator. Now I go on to 4. I divide 4 by plus minus 1. Well, 4 over 1 is 4. So we get plus minus 4. Then I divide the 4 by the 3. 4/3. Plus minus. I divided the plus minus 4 by the 4 possible denominators. Now I do the same with 8. I divide 8 by 1. Get plus minus 8. Then I divide 8 by 3. I get plus minus 8/3. These are the possible zeros. Those are the only possible rational zeros. It may turn out that the square root of 2 over 5 is a 0. What does it mean to be a 0? It makes this expression 0. Why don't I have it on my list here? It's not rational. Okay, this only gives you the rational zeros. 1, 2, 3, 4, 5, 8. There are 16 numbers here. These are the only possible zeros. There are rational zeros. Since 3 over 12 is not on this list, that tells me that 3 over 11. Since 3 over 11 is not on this list, that guarantees me that 3 over 11 will not make this 0. Okay, these are the possible rational zeros. They are the possible ones. Now, suppose we have this polynomial. Suppose f of x is x cubed minus 2x squared minus x plus 2. Now, suppose f of a equals 0. I claim that x minus that root, anything that makes the function 0 is a root. I claim x minus a must be a factor. I'm going to prove that it's true. Proof. So this is what we want to prove. Suppose otherwise. I mean, after all, either x minus a is a factor or it's not a factor. Suppose otherwise. That is, x minus a is not a factor of f of x. Okay. So when you factor f of x, if x minus a is not a factor, that means the first factor will be x minus a number different than a. And the second factor, if there is one, will be x minus a number different than a. And the third factor, if there is one, it will be x minus a number different than a. In fact, this will happen for as many factors as f of x has. And there can be some constant in front. Now, what would f of a be? It'll be k times, well, a minus not a. All I know is it's not 0. Because a minus a is 0. All I know is that it's not 0. When I plug a in for x here, I get a minus a number other than a. Oh, you mean I don't get 0. This factor, not 0. All the other factors, not 0. We're assuming that k is not 0, okay? Well, there's a problem here. Because f of a is supposed to be 0. So, if k is not 0, and you multiply it by a non-zero number, You multiply that by a non-zero number, by a non-zero number, by many, many non-zero numbers, you won't get 0. You know, let me just write it slightly differently. K is not 0. This answer, this will not be 0. But f of a is given to be 0. Suppose f of a is 0. I claim that x minus a must be a factor. So I tried my best not to have x minus a as a factor, but it didn't work. It led to a contradiction. This symbol means a contradiction. This here is not 0, and this here is 0. Okay, f of a is 0, but what f of a, on the other hand, if f of a doesn't have x minus a as a factor, it's not equal to 0. How can 0 equal a non-zero number? So, x minus a, either it's not a factor or it is a factor. If x minus a is not a factor, I run into trouble. So x minus a must be a factor. If you have a 0, you have a factor. If you have a factor, you have a 0. Now, if we have that f of a is equal to 0, that is, if we were going to use synthetic division to find f of a, what's going to happen is you're going to have some numbers here. You're going to put some 0. You'll get some numbers here and put some numbers up here. But in the very end, you're going to have 0. You're going to have 0. So, if you do synthetic division for a, then you're gonna find out if a is a factor, if a is a root or a is a factor. They're same. A is a factor means a is a root. A is a root means x minus a. Sorry, if x minus a is a factor, that means a is a root. If a is a root, x minus a is a factor. If you plug in 0, a, if you plug in a and you get back 0, then you found the root. That is why when you find the list of possible rational roots, you test each one out and you see whether or not you get a 0. If you get a 0, all is good. If you don't get a 0, try another one. Okay. Let us consider this one. Let's find all the roots. This one doesn't say list them. It says find. Find all the roots for, say, x cubed minus x squared minus 5x or plus 5. Find all the roots. So let's list the possible rational roots. The numbers that go into 5 are plus minus 1, plus minus 5. The leading coefficient, the one with the highest exponent of x, is 1. The numbers that go into 1 are plus minus 1. If you do this number divided by that number, you get plus minus 1 over 1, which is plus minus 1. If you do plus minus 5 divided by plus minus 1, you get plus minus 5. These are the possible rational roots. Let us try negative 1. The coefficients are, coefficient of x cubed is 1, x squared, x, and constant. Put a 0 here. Add, you multiply, you get negative 1. You add, you get negative 2. You multiply, you get positive 2. You add, you get negative 3. You multiply, you get 3. This is 8, which is not 0. That is, negative 1 is not a rational root. Let's try 5. Let us try 5. 5, 1, negative 1, negative 5, 5. Get 1. 5 times 1 is 5. You add, you get 4. 5 times 4 is 20, which goes there. You add, you get 15. Now, we really want negative 5 there to get 0. Positive 5 times positive 15 is not going to be negative 5. It's 75. We get 80, which is not 0. That means positive 5 didn't work. Let us try 1. 1, negative 1, negative 5, 5. Put a 0 down, add. So, 1 times this number is always going to be this number. That is, that number just goes up. You add, you get 0. 1 times 0 is 0. Ooh, you get negative 5. You bring it up. You got 0. That means that x, that is 1 is a 0. X cubed minus x squared minus 5x plus 5 is equal to x. Since this is a 0, x minus it must be a factor. Now, what's the other factor? If the problem started with x cubed, that first number is the coefficient of x squared. X squared plus 0x's, which I won't write, minus 5. Now, this is equal to x minus 1 times, let's do this over here. X squared minus 5 is x squared minus the square root of 5 squared. This is the difference of things being squared. X is being squared, square root of 5 is being squared. I write down the two things being squared in brackets 2 times. One gets a plus, one gets a minus. Now, the problem said find all roots. Well, now that we have it factored completely, when is this 0? When x is 1. When is that 0? When x is negative square root of 5. When is this 0? When x is 5. Those are the roots. 1 and plus minus square root of 5. You could have written it as x equals 1 and x is equal to plus or minus square root of 5. Either one are acceptable answers. So and notice that the plus and minus square root of 5 are not rational. They are irrational. But I was still able to find them. Now, let us just talk about this one more time. When we have x squared minus 5, and you want to find find the possible zeros. It could have been, in theory, that this number up here would have been 25. And there would have been a lot more numbers that went into 25. And I wouldn't want to have to check all of those numbers to see which one, if any, makes x squared minus 5 equal to 0. What I can do is start all over and find the possible zeros here. The only numbers that go into 5 evenly are plus minus 1 and plus minus 5. The only numbers that go into plus minus 1 are, the only numbers that go into 1 evenly are plus minus 1. This tells me that the only possible rational zeros are those numbers. And it is very possible that this number here could have been a 25. So the list of numbers that went into 25 would have been a little bit longer. In fact, only 2 extra numbers. Okay, but what I'm getting at is, if you read, it could have been, this number could have been worse. It could have been 36. And a lot of numbers go into 36. Like 1 and 2 and 3 and 4 and or 6 and 9 and 12 and 36 and 18. All of these numbers go into 36. Now, after you did the synthetic division, you found out that 1 worked, and then the next polynomial, x minus 1 times this polynomial, there's no need to try all this long list of numbers, because the only ones that could be possibly true for x squared minus 5 are those numbers. So keep that in mind, that after you reduce and you get something other than linear, you might have a smaller number of possible rational roots than compared to the beginning polynomial. That is actually quite important. And now we're going to play a little game. Find a polynomial with x equals 2, 3, and negative 4 as its only roots. Let's assume by only, I don't mean that the multiplicative of the root can be more than 1. So, one such polynomial, well, if 2 is a root, then x minus 2 must be a factor. Because again, if all the factors were different than x minus 2, if all the factors were different than x minus 2, now p of 2 would be 2 minus something other than 2. 2 minus other than 2. Well, I don't know what I can't give you the exact value of 2 minus a number different than 2, but I can guarantee you it won't be 0, because only 2 minus 2 would be 0, but that's not 2, and that's not 2, that's not 0, and this is not 0. If you multiply all these non-zero numbers together, you won't get 0. But that's a contradiction, because if 2 is a root, p of 2 must be 0. That is, I was greatly mistaken when I said x minus 2 is not a factor. It is a factor. Likewise, x minus 3 is a factor. And x minus negative 4, which becomes x plus 4 is a factor. Now, why did I say the word a versus the word the? Find the polynomial. That would mean that there's only one such polynomial. But that's not true. If I write a 7 here, the only roots are 2, 3, and negative 4. Or if I wrote a 17 in front. Okay, so it's not the polynomial. One of your classmates can write this, and another classmate can write this. Of course, the order that the classmates write these three factors doesn't matter. Another classmate can write p of x is equal to 2/3 times, let's say 2/13, times x minus 3 times x minus 2 times x plus 4. They switched around the three factors. Okay, you can put any number in front. That is why it says find a polynomial, not the polynomial. Suppose I tell you the roots are x equals 2, x equals 5, x equals 1 are the only roots of a fifth degree polynomial. This time when I say only, the multiplicity can be 1 or larger. I'm telling you, okay? If you were just given this problem and you weren't told that the multiplicity can be larger than 1, one can argue you can't do this problem. So now, I know for sure that a polynomial that have those three roots is equal to some non-zero constant times x minus 2 times x minus 5 times x minus 1. But if it's a fifth degree polynomial, there should be 5 zeros. I only have 3. Well, you know what? I could give a fourth one as x minus 2 and a fifth one as x minus 1. The only zeros of this polynomial are 2, 1, and 5. Another way of writing this is you have x minus 1 being multiplied by itself 2 times. And you have x minus 2 being multiplied by itself 2 times. And lastly, x minus 5 with an understood 1. Notice that these exponents add up to 5. If you square this, you're going to have x squared plus lower terms, like 2x plus 1. And when you multiply this, you're going to have x squared plus lower terms, when you square this, times x minus 5. When you multiply this by this, you're going to get an x to the fourth term. But when you multiply x squared by lower terms, you'll get less than x to the fourth. And when you multiply the lower terms by x squared, you'll get less than x to the fourth. Lower than x squared times lower than x squared will be lower than x squared. So you get x to the fourth plus lower terms times x minus 5. when you multiply x to the 4th by x, you're going to get x to the 5th. And when you multiply x to the 4th times 5, you'll get minus 5x to the 4th, lower than x to the 5th. And when you multiply lower terms, that is, if this is to the 4th, the lower terms are cubed and squared, etc. When you multiply them by x, you won't get anything higher than x to the 4th. I mean, the largest factor this can have is an x cubed. Multiply it by an x, you get x to the 4th. And when you multiply by 5, the largest you can get is like 5x cubed. You're going to get x to the 5th plus lower terms. Okay, adding the powers with their integers, positive integers, up to 5. Up to exactly 5 would be fine. Another classmate could have a different, call it k prime, or the same, can have some other constant different than 0, and again, they're going to have x minus 2, x minus 1, times x minus 2, times x minus 5. And the powers have to be at least 1 for each of these. They have to add up to 5. Like maybe 1, 1, that's 2, so that has to be 3. Another student, k double prime, they're going to have x minus 1, x minus 2, x minus 5. Maybe they'll have 2, 1, that's 3, and 2 more. This answer, this second answer, this third answer, they're all different. But they have these 3 zeros, and only those 3 zeros, and the degree of the polynomial is 5. This completes the section on rational roots. Basically, finding all possible rational roots. The rational root theorem.